All right, number 65 on the study guide. Here's the deal. I could do this as a t-chart. I could go through as a t-chart and I could plug in x values. I mean, we could start over here where, what is this? X is -7, -6, -5, -4, -3, -2, -1, 0, 1, stop at 1. I'd stop at 1 because this says x is less than or equal to 1. I would highlight all of those as yellow because this one right here is a yellow one. It's when x is less than 1. And then I would start over again at 1 and go up now 2, 3, 4, 5, 6, 7. And I could highlight all of those green and I could plug those in and I'd be able to figure out what my graph looks like just by plugging those values into the appropriate equation. But I'm not going to do that with you today because that's the hard way to do it. I'm going to do it the easy way. But this will work if you forget the easy way. Now, also want to point out that there's a little typo right here. There's a negative on your screen. There shouldn't be. It should be a plus. It should just be x is less than 1, and then this is x is greater than 1. That should all it should be. So let's do the 2x plus 5 part first. So notice I highlighted this side on the left because this is all the parts where x is less than 1. And I highlighted that yellow, and then this one I made green, and I highlighted everything after 1 green, right? Because this is when x is greater than 1. That's all I'm doing. See, x is greater than 1 over here, x is less than 1 over here. Simple. So what does 2x plus 5 look like? Well, it's actually pretty easy to think about. Because I want you to think of if y equals mx plus b, well, you have 2x plus 5. You should know exactly what this is. 5 is your y-intercept and 2 is your slope. So 5 is my y-intercept. I'm just going to go up here to 5, mark it. Now, it's going to go up 2 over 1. And now, I don't have much room to go up 2 over 1 because that's my border. I'll deal with that in a second. But I could go back 1, down 2, back 1, down 2. So let's go ahead and do that. And just enough till I know how this thing's going to look. By the way, I should recognize that 2x plus 5 or y equals mx plus b is a line. So this is just going to be a line. There's nothing more complicated about it than that. It's just a line. But the real interesting thing is what happens right here at 1. Because at 1 it says it could be equal to 1. So when I get to 1, I'm going to make a solid dot and color it in. Alright. That's all there is to it for that one. The next one we should recognize is an absolute value function. And we said that absolute value functions look like this. And so we should be able to recognize pretty quickly that that's our h, and then there is no k, right? There's nothing out here as a k. So our vertex, we should be able to tell our vertex would be at 2, 0. There's our vertex. So I'll do this one in blue just so we can see the difference. So that's 2, 0. That's the vertex right there. And our a value is just a positive 1. And I told you guys from chapter 1 that the a value, the number out here, is simply the slope on the right side. So this thing has a slope of 1, but only on the right side. On the left side, it has the opposite slope. So that means it's going back to over here. It's going to go up this way. However, we have a border here, right? When x is greater than 1, this function can only be when x is greater than 1. So it can't go past this line right here. And it's actually not equal to 1. So it stops right there. We can't even, here it was equal, so we could do a solid dot, but here it's not equal. So that's when I do an open circle and then connect it. And that's what that function would look like. That's the graph. Now, if you were to go through and plug in these points, obviously the yellow numbers you plug into the yellow equation, right? You'd get some y values. The green numbers you plug into the green equation. Well, you would get the points on this graph. Let me just demonstrate that for you quickly. Let's pick a random number like -5, okay? If you plugged in -5 up here, -5 times 2 is -10. -10 plus 5 is -5. So if you plug in a -5, you should get -5. Well, let's find that point on the graph, okay? I'm going to circle in red so we could find it. -5, -5. Well, 1, 2, 3, 4, 5. 1, 2, 3. Interesting. It's that point right there. It's a point on this graph. And it would be the same if you filled in all these. You'd get all of these points. It's -4, -3, -2, -1, 0, and so on. Let's talk about green ones. Let's pick a random green one to do. Also doing a red. Let's pick like 6. Okay, if you were to plug in a 6 here, 6 minus 2 is 4. The absolute value of 4 is still 4, and then nothing's happening really on the outside, so it's just 4. Well, where is 6, 4? Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Well, look at that. It's a point on our graph. And so that would keep happening as you plugged in these points. You'd keep getting values on this graph. The thing that you need to know is what happens right here on this line, and that all depends on this domain column. Which side is equal, which side is not equal. That tells you equal means it's a solid, not equal means it's an open circle. These lines cannot pass, these graphs cannot pass this border of x's where x is 1, because it tells you right here that it can't. It says x is only less than or equal to 1. So this graph will never be over here when x is like 2 or 3. And this one is x is only greater than 1. So this graph will never be over here when x is like -3, -4. And that's it.